Hello, my name is Roland Reyer. I'm a technical specialist at Autodesk Media Entertainment in Europe. In this video, I'd like to talk about my new print pack for Bifrost. Okay, here are some simple examples of how to print something in Bifrost. There are some obstacles at first, but it's gonna get easier, I promise that. So let's first look at a very simple example of printing a so-called static text. For that, I'm going to use the node print static. And for my example, I'm using this time node here. Let's say I don't know what comes out of the time node and I want to inspect these values. So first, for the print static, I'm going to use the right mouse button menu to create such a value node, which is a string node. And then I can type in some sort of a description for this value that I want to expect. You see on the screen that it prints it out immediately. Okay, that works so far. And then I want to append a number, one of these values here. Let's use the frame, but I can't plug that in directly. I have to convert it to a string. So I'm going to use the number to string node to convert it, and then I plug it in as well. So now I have already two lines of text. That was not my intention here. I wanted to say, description equals 1 or something like that. In the print static node, you find at the very bottom here the separator string. So this print static will chain up all the values that come in, all the strings that come in. It will chain them up using this string here as a separator, which is a new line at the moment. I could use an equal sign, but the next description and number pair, then there I have no separation for them. So a better method would be to use the node join strings. So I plug my description in here, and then I get an error already, so I have to make it to a fan import, and then I can plug in my number as well, or the string of my number, and then as a separator I type an equal sign, and all of that I put into print static, and finally I have my description of one value here. And you see, if we do it all by hand, then it's really painful, and it really asks for some simplification. And so what I did was this here. So I built a node called value to string, which includes a description already. And then you plug in any kind of value, integer or float or even vectors. And it turns that into a string that you can already plug into the print static. And here you see that's much easier to, combine these things here. So the next string that I plug in, let's say for the ticks, goes into the next line because the print static has this new line as a separator between the strings. So that is already very easy. If you've done it a few times, you wish you had it even easier. So what I did then was to build this node here, a for values to string node, which doesn't display anything. So when we plug it into the print static here, it doesn't display anything unless you plug something in. So for example, a frame into the first value, then you see the frame already and you can leave it there. You don't have to write a description, but of course you can do so. So let's write frame and equals, and here is my first string. And then the next string isn't much more complicated. So I simply plug in the ticks and write a description. And here you go already. So that is the easiest way to print some values on the screen, no matter what it is. The for values to string has a separator to separate all these pairs of description and value from each other. So it's going to chain them together using a \n. You can also use a comma space to chain them together to create one line of description and value pairs, which is a good way for the next example, the print scrolling. So for print scrolling, I'm using a similar setup. We have the time node here, we have the print scrolling over here, and the for values to string node over here, which I will connect to the print scrolling. Before I even start, I changed the separator of the for values to string node to a comma in the space because we want to connect all the different pairs of description value into one line to create a scrolling screen. So I take the frame value here, plug it in, and you see the value already there. And then next thing I plug the ticks in. And the third one will be the seconds, and then I go and make some descriptions. So the first one is the frame, and the second one is the ticks, and the third one is the seconds. Okay, and you see already it starts scrolling these values. So whenever I make a change here, add another value or type in a description, it adds a new line to the bottom of the whole thing. So in fact, it's scrolling this screen whenever there's a change. So for example, when I hit play, you see that it starts scrolling this thing up and up and up and always displays the new line at the bottom here. You can of course change the number of lines here. The total number is set to 20 currently. Number of columns, so after 80 characters it will make a new line automatically to break it, to wrap the line. So all of these things can be set here. And this also applies to the static display. If I want to move this thing around, there is in all the print compounds this transform section where you can either type in a translation, rotation and scaling, or you can plug in a matrix. So for example, I just released my second version of the manipulator field, and in the shelf you have one button that creates a TRS manipulator, a translate, rotate, scale manipulator node, which delivers in your scene this matrix of that locator here, and you can plug that into your print compound and then simply move the manipulator around, and that will move the whole writing around. And of course you can rotate and scale it to your liking. So let's undo that and do something else which is very cool that you can do with it. So let's say you have this scrolling screen here and you position it somewhere in your 3D space, but what's actually happening is somewhere else. So you look over here and then you have to go back to your print screen to find or to see what it's printing. So there's a better way for that. We simply parent this position manipulator to the perspective camera, and then we go in here. This position manipulator inherited all the transformations of the camera, and when I zero that out and then move the manipulator slightly in -z, so -0.5 for example, and scale it smaller, let's say 0.01, then you see, oh, suddenly my whole scrolling screen is parented to my camera. So now you see I can move around my camera, and it's, you know, this scrolling printing is sticking to my camera. I can now go to the print scrolling node and for example scale this down even further, and then use these values here to position that in relative to my camera window. So I can move it down here, for example, and it will stay there. So now I have this scrolling information ticker on my screen sticking to my camera, and I can do with my camera what I want, and it will always show me that information in my screen. That works with print static and also with print array. That is the next one we're going to look at. The ability to print arrays was definitely a key point in the development of the print pack. Look at this example here. From an object from a geometry that was imported from Maya, I'm using the node get property keys to get information about the structure of this geometry object. It is an array of strings as a result, and it gives me information about, you know, the different parts of the geometry. But from this plug here, I don't know which parts are actually output in which order. From a watch point, I simply get the size of this array. So in traditional programming, I would definitely use a print statement to just print out this array to get an idea how it's structured and then go on with the processing of it. Now, what I've done here with my print array was a simple method to do exactly that. So with the print array node, you simply plug in any kind of array, and then it prints out, or displays on the screen the contents of this array. And in this example here we see some sort of a header, which is a description that you can set. So for example, you want a different description, you can type it in here. Then the type of the array, the number of elements. In this case, because it's a string element, it shows you the min and max lengths of the strings, and then the contents of the array. So we have 12 elements, and these are the 12 elements. And now I can go on because I know, okay, first comes the face component, and then we have the offsets, etc., etc. So that's the order of this whole structure. That was, as I said, one of the key points that I needed for my work in Bifrost. Now, while this is pretty simple, if you just have 12 values or so, it's actually not a problem. But imagine you have something that is more. So let's delete this node here and get more points. So I'll take this object and use a get point position to get the position of all of these points. And I have already increased the resolution of this object. So the resolution is currently 31 by 31, which results in 1024 vectors for the position. So let's have a look what it's like when I plug that into print array, and you see that the performance is really amazingly fast. Now we are not displaying all 1024 values here because currently the display is restricted to 25 lines in 2 columns for each start, and yellow you see here, that's the end of the array. So just to restrict the number of values that we are displaying, I brought in these number of columns especially, but we can do it so that I increase the number of lines to 100 and the number of columns to 6, and then we should be able to see the complete array. So these are 1024 values. And now if I take this object here and move it around, you see that with 6 frames per second, it's updating all of this information. So all 1024 vectors, 3D vectors, the position vectors that we see here are updated at once with a frame rate of 6 frames on my laptop here. So that is not bad. So the performance is really good, so that even larger arrays can be printed and watched here in such a panel. You can of course restrict what gets displayed. So for example, here's an offset value that you can set to say, okay, I want to see only the values starting from position 600 here. So let's type in 600. So the first index that is displayed here is number 600. So that way you can restrict how many values you see here. And as I said, as a default, we just had 25 lines in 2 columns for start and the end. That is already a restricted version of what we have. So print array is super helpful in printing large, numbers of values that you just want to inspect to get an idea about the structure or, general range of values and stuff like that. It's also super easy to use because you just plug the array in here and that's it. Like with the other compounds that you've seen so far, you have the transform section here where you can plug in a matrix or translate, rotate, scale the thing manually to move it around on the screen, and even, parent it to your camera to move it around with the camera. Okay, that was print array. The next example will be print points. The idea behind print points was that I wanted to print arbitrary information at point positions, and these point positions could be vertices of a geometry, for example, or maybe particles, or maybe even a data probe, like a line that I move around on the screen to measure something in space and display the information there where it measures it, or, in a raster of points. So in this example, I used a fractal noise field to displace this polygon plane here to just apply some noise. And we're going to use the node print points to display some information here. So the easiest way, or the easiest start here, is to say I'm simply going to extract the point position from this object here with get point position. And then, all of these positions I can plug in as point positions. So that's how I define where the information is displayed. And then for point values, I provide an array of the same size with the values that I want to display. And the easiest method, or the easiest thing to do here, is to also plug in my positions into point values. And as you can see already, we have all of these little vectors here displayed at the point positions. So they are all a little bit too big, so I go into the node and use the scale to scale them down all together. And I can even, say I want to have them a little bit offset to the right and a little bit offset to in the y-axis to better see them. So now we have a display for every point here, and when I move this thing around, so for example, when I pick this object and move it around in X and Y, then you would see how all of these values change and are updated interactively. We have around 1000 values here on the screen displayed at the same time. Now the position is a little bit boring. Another thing that I could do with my position is say I want to sample the field. So sample that scalar field, which is the fractal noise here, and I will sample it at the position that I'm extracting here. And this is now my new value. So instead of the X, Y, Z positions, it's going to display all of these little scalar values here, and I can bump up the size a little bit here. So now I see all of these values displayed at the point positions, and of course they are moving around together with the point positions. That's nice already, nice to have. And we can go further. So here this print points node has an input for colors as well. So by default there's nothing plugged in, and it simply uses the color that is set in the node. That's this one here, the line color. But I can also calculate some sort of a color. So for example, I can use a linear interpolation node. So this one here, and say I want to use something like float 3s. So my first color should be green, that's where 0 is, and the second color should be red, that's where the 1 is. And then I plug in, this value as a fraction. Actually, the fraction should be, unplug this, the fraction should be just a float, an array of floats. And then it spits out a number of colors. So I plug this one in here, and then you see suddenly, my values are displayed in colors in green and red as I entered them into the linear interpolation. So let's use the fractal noise field to change the frequency here and to see how the values change and how their colors change according to what happens to the points there. So this way I can display any kind of information, and imagine you can use more than one print points node to display more than one information on a per point basis and different colors and so on and so on. So this is super cool. You realize that this of course has also to do with the number of points here. This is just 1000 points, and you see in the nodes it is restricted to 1000 points already to make sure that we have enough performance to display all of that. You can decrease the number of points that are displayed by, for example, displaying only every second one. When you set the dropout to 1, then only every second point is displayed here. When you set it to 3, only when you set it to 2, only every third point is displayed, and so on. So now I've already drastically removed or decreased the number of points. And another thing that you can do is to use a field. So here in point selection, there's a plug for a filter field. So let's use a very simple field. For example, in my manipulator fields, I provide a simple spherical field. So I create one for my graph here and plug in that field into the filter field section. And now this manipulator on my screen, when I scale it up, it acts as a filter for all of these values. So let me increase the size of these values so that we can see them a little bit better. So now it acts as a filter for all my values only where there is a value for the field. So wherever it is non-zero, it displays the points. So that way you can use millions of points on the screen and just filter those that you want to see. So this was a very quick introduction to the print functionalities. There's more stuff that you can do with these notes. Just play around with them and, use your imagination, what else you could do with it, and have fun with it. So if you find anything that doesn't work or you need something else that's built into these notes, please let me know.